Okay, so the next thing we're going to talk about here is percent error and percent difference, which are two calculations we can do with our data. Now, they do serve two different purposes, and we'll talk about that in a second, but they both allow us to analyze our results. So we'll start with percent difference. Percent difference, the key is it's a way to compare two values, okay? Two values that you measured, all right, in the lab, and we're going to use it to see if there is a significant change between those two values. So you might have two different times, for example, that you were measuring, and you want to see if there really was a significant change between those two times, or if it was simply error that caused those two times to be not exactly the same. That's where percent difference comes in. It helps you to quantify it, because if you're measuring something that takes an hour, a 1 second difference really is not significant. If you're measuring something that takes half a second, a 1 second difference is very, very significant. And so this formula here allows us to calculate percent difference and quantify how much that difference really matters. So the way we calculate it is value 1 minus value 2, all right, over the average of the values. Do notice that we have absolute value signs around those, okay, because we're going to always have a positive number here for percent difference. All right, one other thing to note, and I didn't write this here, but this does calculate to a decimal, all right? So a lot of times what we'll do is we'll multiply by 100% to take that decimal, all right, maybe 0.23, and convert it into a percent, all right? So that's something to keep in mind, all right? So percent difference, useful for comparing two values that you measured in the lab to see if there was a significant change. That's the key. So percent error is the other tool that we have, and the key difference here is for percent error, we're going to be comparing some value that we measured in the lab to the known or accepted value. For example, maybe in chemistry you calculate the molar mass of some element, right? You might want to compare it to the accepted value that you find on the periodic table. Or maybe you're calculating the density of water and you want to compare it to the accepted value. So you're always comparing it to something that you did not measure, that's an accepted value that you're looking up in a textbook or on a chart or something like that. So that's the key, is comparing a value to a known value to determine how accurate your results were. The way we calculate percent error is given by this formula here. Rather than being value 1 and value 2, we have the actual value, all right, the accepted value, minus the experimental value. That's what you calculated over the actual. Once again, this is going to spit out a decimal, so sometimes you could write that times 100% to convert that decimal into a percentage, or you could just convert it, okay? But with percent error, it's comparing something that you measured in the lab or calculated in the lab to a known constant, a known value. A lot of times with percent error, percent difference, we'll put it in a chart along with something else, right? So maybe we have a condensed form like we do here of our results, okay? Just simplified down to really the key pieces of information. And then we have our column here showing the percent difference. What I do that I think is a nice technique for percent difference especially is compare it back to the original, your initial value. So in order to get these numbers here that I have, these percentages, what I did was I took this value, 1.25 seconds, and compared it back to my original 0.91. And then I took this value, 1.53, and compared it back to my original 0.91. And the same thing on down the line. So I kept comparing each of these values back to the original, okay? And what I end up finding is that over the course of all these changes in length, I actually end up with a 92% difference between the initial time or period and the final time. So that's significant there, all right? That would be almost 100% change or 100% difference, which is absolutely significant. So that's one way of using it. That's not the only way to use it. There are other uses, but you kind of just have to think about what your goal is in the lab and how you could use this technique to help accomplish that goal.